This is the core pure 1 chapter 2 Argand diagram and mixed exercise 2 with the questions for the flag. But you know there are too many flags here. You can tell. So here I may do only E, P together. So number 2. Z cube plus z squared and plus 3z minus 5 of this is f of z, and negative 1 plus 2i is the solution. Then negative 1 minus 2i is another solution. So when we have two solutions here, we can find the quadratic factor, which is z squared minus sum of two solution, which is negative 2, so plus 2, z, and plus product of two solutions. So negative 1 plus 2i times negative 1 minus 2i is 5, and z minus p. So this is f of z. So we can find p is 1. So therefore, z equals negative 1 plus 2i, z equals negative 1 minus 2i, and z equals 1. The all roots negative 1 comma 2, negative 1 minus 2. Just briefly, these two conjugate numbers on Argand diagram, they always the reflection in the x-axis because they have same real part but opposite imaginary part. So when we plot them on the plane, we can tell it always like this. And this means the modulus of the number and the conjugate always the same. This and this is the same. But the argument like this and like this, let's say, is always opposite. So this is just a small tip. And here another z. Oops. Another z, 1 comma 0. So let's call it z1, z2, and z3. Prove these points the vertex is right angled triangle. We can make it, calculate it, the size, the distance of the 3 points. So here, 1 comma 0, negative 1 comma 2, 1 minus negative 1 squared, plus 0 minus 2 squared, square root to 8, same, square root to 8, and this one is 4. So we can tell this is a right angle because this satisfies the Pythagorean theorem. Number 3. Now we have negative 1 plus 4i as a solution. N means negative 1 minus 4i is another solution. So now we have one of the quadratic factor, which is z squared minus sum is negative 2 plus 2z, and the product plus 17. And z squared, we don't know what it is, plus az plus b. Yeah, we can find b easily because that is 2, as the constant term is 34 on the left-hand side, and we have 17b. And we can find z cube, like 2z cube, 2z cube, plus a z cube should be negative 1z cube, which means a is negative 3. So that is, the solution is z equals negative 1 plus minus 4i, and z equals, this trinomial is easy to factorize. So z minus 1, z minus 2. So 1 and 2. And 1 and 2. And negative 1 plus 4i. So negative 1 minus 4i, negative 4. When we say the imaginary part, it doesn't contain I. So this is not negative 1 comma 4i. This is just negative 1 comma 4. And number 10. Given a equals 4, find modulus of z. So 4 plus 3i, 2 plus 4i. I'll give you the tip. So when you say like this, actually we need to figure it out what is real part and what is imaginary part. So here, this one, 2, let me make it 1 plus 2i, 4 plus 3i, 1 minus 2i, 1 minus 2i. So 2 and 5, 10. And 4 plus 6, which is 10, plus 3 minus 8 is 5i. So we can tell this is 1 minus 0.5i. So modulus of z is 1 squared plus 0.5 squared, which is 0.25, 1.25. So 10, 125 is 25 times 5, so 5 squared root to 2, and 10, am I right? So 100, 125, yep, like this. So this is how we find, but actually if you find like this, 4 plus 3i over 2 plus 4i, when we find the modulus of here, 4 plus 3i modulus over 2, we can take it out. Modulus. Then square root to 25, which is 5, over 2 square root to 5. So when we rationalize it, 10, 5, square root to 2. Oh, yeah, we can simplify it. So this is the tip. Number B, show that there is only one value of a. Argument should be pi over 4 and find this value. Okay, so the argument is a little bit different. So argument of z means when you find the argument, you need to find arctangent, imaginary part over real part, like this. So arctangent, imaginary part here, 2 minus ai, 2 minus ai. So 4 plus a squared. And imaginary part is negative a squared plus 6. And real part, 2a minus 3 plus 3a, which is 5a. So like this. Should be pi over 4. So tangent pi over 4 equals, we can apply tangent on both sides. So tangent pi over 4 equals 1. And a squared plus 6 over 5a. So negative a squared plus 6 equals 5a. A squared plus 5a minus 6 equals 0. So a should be 1, like a plus 6 and a minus 1 equals 0. So a can be negative 6 or a can be 1. Why I have 2? It says only one value. Let's see. When a equals negative 6. So this is the result at this moment, but we need to verify it. A equals negative 6 or a equals 1. When a equals negative 6, the imaginary part and real part, the coordinate is what is that? Negative 6, negative 30, negative 30 over 36, 40, comma, 40, negative 30. And when it is 1, then 5 over 5, comma, 5 over 5. You know, this is the on the quadrant 3. When quadrant 3, the argument is not positive pi over 4. Actually, the argument is 5 pi over 4. This is not the correct one, because this is always the problem for when we find the argument with this algebraic method. Because the algebraically, the fraction, when we have negative over negative and positive over positive, the result is always the same. But negative over negative is on quadrant 3, and positive over positive, this is on quadrant 1. So only this has argument pi over 4. This has argument negative pi, 3 pi over 4 or 5 pi over 4. So find the value is only a equals 1. You need to show all this reasoning. And number 14, point P. So this one is z, when z is x comma y, x plus yi, negative 1 plus I. So the distance from negative 1 comma 1, z has the distance of 1. So negative 1 comma 1. And distance should be 1. So this is a circle like this. So Cartesian equation, this is the circle equation. X plus 1 squared plus y minus 1 squared should be 1. The locus, yep, oh, not x, real part and imaginary part. Greatest and least possible value of z. So here, this z, we need to understand what is this modulus of z. Modulus of z is z minus 0. Modulus of z is z minus 0, like the distance from the origin. So all those possible points on this circle, the distance from the origin, the largest value and the smallest value can be, this is the largest value, like a farthest. So here square root 2 and the radius is 1. So greatest is 1 plus square root 2. And least is here. So square root 2 minus 1. What about z minus 1? Z minus 1 is here, because this is the distance of between z minus 1, 1. So 1 comma 0. So from here to z, the distance, the longest, the largest distance, like greatest, always pass the center. So we can make it like this. So from here, this is 2 and 1, so this is square root of 5. So the greatest is a square root of 5 plus 1, and least is a square root of 5 minus 1, because it should be here and here. And number 16, complex number z satisfies this one. So z minus negative 3 plus 6i equals 3. So the center is negative 3 comma 6, and the radius is 3, like this. So show that exact maximum value of argument z in the interval is pi over 2. The maximum value of argument z might be here, because it should be the like here, because argument is the quantity, the angle quantity that counterclockwise from the real positive axis. So this can be the maximum. So this is the maximum. So from here, this line could be tangent to the circle. So like this and like this. So this is, anyway, this is the pi over 2. So, and this are a congruent triangle. So now we need to find the size of this one of the feet, let's say. And here 0.6 and this one 3. So it uses sine, so we also go for sine. So this is 6. Then the hypotenuse, the calculation is 36 plus 3, or 1, 2, square root of 5. So 3 square root of 5. So in terms of theta, like sine theta, so 3 over 3 square root of 5, like this. Therefore, 1 theta is 1 over square root of 5. So 2 theta means 2 arc sine. Oh no, I mean sorry. Here, arc sine 1 over square root of 5. So here 2 theta is 2 arc sine 1 square root of 5, 1 over square root of 5. Number 17. Z minus 5 modulus equals 4. So from 5, 0, the distance should be 4. So the circle of radius of 4 with the center 5, 0. Real and imaginary. Sorry. And complex numbers. This n argument objective plus 3i. This should be argument minus negative 3i pi over 3. So negative 3i is 0, negative 3. So we start from here and make the angle pi over 3 like this. So this is the one. So we need to find this and that. So we can find easily the argument. What is that? The Cartesian form. So x minus 5 squared plus y squared equals 16, and y equals square root of 3, which is tangent pi over 3, because that is the slope. Square root of 3 x minus 3. So we put it here and solve the equation. So here x squared and square root of 3 x squared is 4x squared minus 10 and negative 6 square root 3x and 25, 9 equals 16, 18. So did I make it well? 16, 9 and 9. Okay, so this is the one. You can use the quadratic formula or use your calculator. I'll just use my calculator to solve this quadratic equation. And if you don't have GDC, I think still you can, some of the just handheld, the calculator is offer this, the polynomial solver. So I hope you have it. So x2, 3,96, 2 decimal places, and 1.14. So this is one of z and one of that z. But this is only real part yet. So now we need to find imaginary part. times square root 3 minus 3, like here. So, so you can use again the calculator. So square root 3 minus 3. Three, oh no, I mean 3,86, 1.14. Negative 1,03. So this is the z. And see, z plus 5 equals theta and z minus 5 equals 4. No common solution. Range to possible theta. So when we express it in like the geometrical graph, the first one still 5 and 1 and 9 circle, radius 4. And the second one, we start from negative 5 and make the angle theta. So from here, so this can be the maximum. No, I mean no common solution. So this is the, from here to here, it has common solutions. So other than that, then we can find the solution. So let's find it. Here this is like this, and 5 and 10, which not 5, this is 4 and 10. Then we can find theta as arcsine 4/10. So arcsine 4/10 equals 0.444115. 0.4115. So here it should be negative 0.4115. So theta should be larger than 0.4115 and smaller than pi within the domain, and larger than negative pi and smaller than negative 0.4115. That's it. And number 18, given, so z plus 5 minus 5i. This is the one like z minus negative 5 plus 5i equals z minus 6 plus 3i. So negative 5, 5 and 6, 3. So the distance from 2 points, it like equidistance points. So we know that the like bisector line, all the points here are like equidistant from both points. So this is just the sketch of the locus, the blue line. And we know this is the bisector line. And Cartesian equation. So the midpoint here, 1/2, 4. And the slope. The current slope is that this red line has the slope of 2/-11. So the blue line has the slope, it's negative reciprocal. So y equals 11/2, x minus 1/2 plus 4. Least possible value of z. Oh, my drawing look like it passes the origin, but actually we are not sure about it. So let me just move a little bit like this. So from origin to the line here, this should be the minimum distance. So whenever you have the questions to ask about the minimum distance or about the shortest distance or something like that, you need to understand that always come with perpendicular relation. So this is just, so anyway, this is perpendicular. So now we know this black line has the equation y equals to negative 2 over 11 because it has the same slope with here, x. And we can find the intersection with that here. Then y equals 11 over 2x minus 11 over 4 plus 8 over 2, 16, 11 over 4 plus 16 over 4. So plus 5 over 4. This and this together. So you can solve the equation and find the distance here. No, I mean find the coordinate here and find the distance. Number 19. Cartesian equation of locus. So again, 4, 0, 0, 8. So the bisector line equation. So 4, 0, 0, 8. So we are looking for this equation, this red one. So now the blue slope, the slope of the blue line is negative 2. Therefore, this one is 1 over 2. So y equals 1 over 2, and midpoint is 2, 4, x minus 2 plus 4. So find the value of z, satisfy this, and also argument of pi over 4. Argument of z, pi over 4 means start from here, and pi over 4 like this. So this is y equals x actually. So we can find the intersection like this. 1 over 2x minus plus 3 equals x. So x equals 6. Then 6, 6. So 6 plus 6i because the coordinate is 6 plus 6, 6. So the Argand diagram here. So this one, the from 8i, it should be like larger distance. So it's here. And intersection of pi over 4 to pi. So it should be here, like this. So the intersection part is here. And number 20. Cartesian equation of this again, z minus 3 minus I, z minus 1 plus I. So the bisector, 3, negative 1, 1, 1. So the midpoint is 2, 0. And the slope is now y, x. So this one negative 1, so this is 1. So y equals 1 x minus 2. So this is the answer for I. And I, this is x minus 2 squared plus y squared becomes 8 because the radius is 2 square root of 2. To value of z, this and this, when they are together. But actually when y equals x minus 2 is easy to calculate. So x minus 2 squared, we have x minus 2 squared of 2, 8, 4. So x minus 2 plus minus 2. Therefore, x could be 4 or 0. So when x equals 4, then y equals 2. So 4 plus 2i. And when x equals 0, y equals negative 2, negative 2i. So now reason for that. So the reason on Argand diagram. So we can draw the graph. So 2, 0, and like this. So this can be 2 plus 2 root 2 square root of 2. And this one is 2 minus 2 square root of 2, something like that. And here, but it should be smaller than that. So inside, like here. And this one, the bisector, x minus 2, 2 and 2. So the graph looks like this, actually. Because when x equals 0, y also 2. So 2 and negative 2, so it's like this. And, but this one, from 3, negative 1 and 1, 1, 3, negative 1 should be, like the distance should be larger. So it should be further from 3, negative 1. So it's the upper part here. This is the one. Challenge. This is the satisfy z minus 3 minus 3i. So the 3, negative 3 and negative pi over 4. So it's like this. So negative pi over 4 like this. So this half line, it should be empty here. This is the first graph. And second one is w minus z equals 3. So w is the distance from z is 3. So from z, 3 means, for example, if z is here, which is not true because it's not inclusive, but anyway, from there it's a 3. Anywhere here is a 3. So all these 3 like this. So here, this is the w, the locus, this and this. And this, which is dash. And all inclusive inside, like this. And minimum value of a w. So from here, the w magnitude, because this is all possible w. So from the origin, so from the origin, this is the distance 3 square root of 2, and the distance is 3. So the minimum value 3 square root of 2 minus 3. Even it is not inclusive, but still there is very close the point on there.